It is generally not recommended to use the lugs at the bottom of a main breaker panel as a feed-through for another panel. These lugs are typically intended for grounding purposes or for connecting a neutral bus. Using them as a feed-through can create safety hazards and potential electrical issues. In the described scenario, the main panel has space for only one sub-breaker, and a 100 amp sub-breaker for the garage has already been installed. This means that there is no additional space to install a 150 amp or 200 amp breaker for the house load. Instead, consider installing a separate 200 amp sub-panel inside the house to distribute power to the house circuits. This sub-panel would be connected to the main panel using a 200 amp breaker or fusible switch. This arrangement would provide a dedicated feed for the house and protect it from any potential faults in the garage circuit. Here is a revised solution. 1. Install a new 200 amp sub-panel inside the house. 2. Connect the 200 amp main breaker in the outdoor. Disconnect the main bus of the house sub-panel using appropriate conductors sized for 200 amps. 3. Install a 100 amp breaker in the house sub-panel to protect the garage circuit. 4. Install the necessary breakers in the house sub-panel to distribute power to the house circuits. This revised solution will provide a safe and dedicated power supply to the house and the garage while ensuring that both circuits are adequately protected. When working with electrical systems, it is important to adhere to the National Electrical Code, or NEC, and local codes. The NEC provides guidelines for safe and proper electrical installations. Here are some important considerations related to this scenario. Firstly, conductor sizing. Conductors must be sized appropriately for the load they will carry. The NEC provides tables that specify the ampacity of conductors based on their size, insulation type, and installation method. For a 200 amp circuit, appropriate conductors, such as copper or aluminum, must be selected based on the applicable NEC tables. Secondly, overcurrent protection. Overcurrent protection devices, such as circuit breakers or fuses, must be sized to protect conductors from overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection for conductors based on their ampacity. The 200 amp breaker in the main panel will protect the conductors feeding the house sub-panel. Thirdly, grounding and bonding. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and energizing the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, minimizing the risk of electric shock. The grounding and bonding requirements are detailed in Article 250 of the NEC. Fourthly, working space. Adequate working space must be provided around electrical equipment for safe access and maintenance. The NEC specifies the minimum working space requirements based on the voltage and ampacity of the equipment. Working space requirements can be found in NEC section 110.26. Fifthly, panel board installation. Panel boards must be installed in accordance with the manufacturer's instructions and the NEC requirements. The panel board must be securely mounted and properly grounded. The NEC provides guidelines for panel board installation in Article 408. Sixthly, sub-panel considerations. When installing a sub-panel, it is important to ensure that it is properly sized for the anticipated load. The sub-panel must have sufficient capacity to accommodate all of the circuits that will be connected to it. The NEC provides guidelines for calculating the load on a sub-panel in Article 220. Seventh, load calculations. Accurate load calculations are essential for determining the appropriate size of electrical equipment and conductors. The NEC provides methods for calculating the load on a building or structure based on the type of occupancy, square footage, and appliances. Load calculation methods can be found in NEC Article 220. Eighth, permit and inspection. In most jurisdictions, a permit is required for electrical installations. An electrical inspection is typically required to ensure that the installation complies with the NEC and local codes. Contact the local building department to obtain the necessary permits and schedule an inspection. Ninth, professional installation. Electrical work should be performed by a qualified and licensed electrician. Electricians have the knowledge, skills, and experience to safely and properly install electrical systems. Hiring a professional electrician can help ensure that the electrical work is done correctly and complies with all applicable codes. 10th, safety precautions. Always follow safety precautions when working with electricity. Turn off the power to the circuit before working on it. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician. In this specific scenario, it is important to consider the following factors. The existing 100 amp subfeed to the garage. The 100 amp subfeed to the garage is already installed and sized for the load. Ensure that the conductors and overcurrent protection for this circuit are properly sized and installed in accordance with the NEC. The house load. Estimate the load in the house to determine the appropriate size of the house sub-panel. Consider the existing appliances, such as the electric range and dryer, as well as any future appliances, such as air conditioning. The main panel capacity. The main panel has a 200 amp main breaker. Ensure that the sum of the loads on the house sub-panel and the garage sub-feed does not exceed the capacity of the main panel. The feed-through lugs. Avoid using the feed-through lugs at the bottom of the main panel as a feed for the house sub-panel. These lugs are typically intended for grounding purposes or for connecting a neutral bus. Using them as a feed-through can create safety hazards and potential electrical issues. The alternative solution. Install a separate 200 amp sub-panel inside the house to distribute power to the house circuits. This sub-panel would be connected to the main panel using a 200 amp breaker or fusible switch. This arrangement would provide a dedicated feed for the house and protect it from any potential faults in the garage circuit. By following these guidelines and consulting with a qualified electrician, it is possible to safely and properly feed the house from the outdoor main panel. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. The installation of a new 200 amp sub-panel inside the house involves several steps that must be performed correctly to ensure safety and compliance with the NEC. Here is a detailed overview of the installation process. Firstly, planning and preparation. Before starting the installation, it is important to plan and prepare. This includes determining the location of the sub-panel, calculating the load on the sub-panel, and obtaining the necessary permits. Choose a location for the sub-panel that is accessible, dry, and well ventilated. Calculate the load on the sub-panel based on the appliances and circuits that will be connected to it. Obtain the necessary permits from the local building department. Secondly, safety precautions. Before working on any electrical equipment, it is important to take safety precautions. This includes turning off the power to the circuit, using insulated tools, and wearing appropriate personal protective equipment. Turn off the main breaker in the outdoor disconnector to energize the circuit. Use insulated tools and equipment to prevent electric shock. Wear safety glasses and gloves to protect your eyes and hands. Thirdly, installing the sub-panel enclosure. The sub-panel enclosure must be securely mounted to a wall or other support structure. The enclosure must be properly grounded and bonded. Mount the sub-panel enclosure to the wall using appropriate fasteners. Ensure that the enclosure is level and plumb. Connect the grounding electrode conductor to the grounding bus in the enclosure. Bond the enclosure to the metal frame of the building or structure. Fourthly, installing the main breaker. The main breaker in the sub-panel must be sized to protect the conductors feeding the sub-panel. The main breaker must be properly installed and connected. Select a 200 amp main breaker that is compatible with the sub-panel. Install the main breaker in the sub-panel according to the manufacturer's instructions. Connect the conductors from the outdoor disconnect to the main breaker. Fifthly, installing the branch circuit breakers. The branch circuit breakers in the sub-panel must be sized to protect the branch circuit conductors. The branch circuit breakers must be properly installed and connected. Determine the appropriate size of the branch circuit breakers based on the load on each circuit. Install the branch circuit breakers in the sub-panel according to the manufacturer's instructions. Connect the branch circuit conductors to the branch circuit breakers. Sixthly, wiring the sub-panel. The sub-panel must be wired in accordance with the NEC and local codes. This includes properly grounding and bonding the sub-panel, as well as using the correct wire sizes and types. Ground the sub-panel by connecting the grounding electrode conductor to the grounding bus. Bond the sub-panel by connecting the metal parts of the sub-panel to the grounding bus. Use the correct wire sizes and types for all conductors. Seventhly, connecting the conductors from the outdoor disconnect. The conductors from the outdoor disconnect must be properly connected to the main breaker in the sub-panel. This includes using the correct wire connectors and ensuring that the connections are tight. Use appropriate wire connectors to connect the conductors from the outdoor disconnect to the main breaker. Ensure that the connections are tight and secure. Eighthly, testing the sub-panel. After the sub-panel is installed, it must be tested to ensure that it is working properly. This includes checking the voltage and current on each circuit, as well as verifying that the grounding and bonding are correct. Use a voltmeter to check the voltage on each circuit. Use an ammeter to check the current on each circuit. Verify that the grounding and bonding are correct by using a continuity tester. Ninthly, labeling the sub-panel. The sub-panel must be labeled to identify the circuits that are connected to it. This will help to prevent confusion and make it easier to troubleshoot problems in the future. Label each circuit breaker with the name of the circuit that it protects. Create a circuit directory that lists all of the circuits in the sub-panel. Tenthly, inspecting the sub-panel. The sub-panel must be inspected by a qualified electrician or electrical inspector to ensure that it complies with the NEC and local codes. Contact the local building department to schedule an inspection. Be prepared to answer questions about the installation and provide documentation such as permits and wiring diagrams. By following these steps and consulting with a qualified electrician, it is possible to safely and properly install a 200 amp sub-panel inside the house. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. It is also crucial to understand the potential issues and hazards associated with using the lugs at the bottom of a main breaker panel as a feed-through for another panel. Here's a detailed explanation. Firstly, intended purpose. The lugs at the bottom of a main breaker panel are typically intended for specific purposes. They are designed for connecting grounding conductors or neutral conductors. They are not intended to be used as a feed-through for another panel. Secondly, ampacity limitations. The lugs may not be rated for the ampacity of the conductors that would be used to feed another panel. This could result in overheating and potentially a fire hazard. The lugs are typically sized to accommodate grounding or neutral conductors, which are smaller than the conductors used to feed a sub-panel. Thirdly, overcurrent protection. Using the lugs as a feed-through would bypass the overcurrent protection device in the main panel. This could result in an overload or short circuit in the sub-panel, which could damage equipment or cause a fire. The overcurrent protection device in the main panel is designed to protect the conductors and the equipment downstream from overloads and short circuits. Fourthly, safety hazards. Using the lugs as a feed-through could create a safety hazard for anyone working on the electrical system. The lugs may not be properly insulated or shielded, which could expose workers to live electrical parts. The lugs may also be difficult to access, which could make it difficult to safely disconnect the power to the sub-panel. Fifthly, code violations. Using the lugs as a feed-through may violate the NEC and local codes. The NEC specifies the approved methods for feeding sub-panels, and using the lugs as a feed-through is not one of them. Code violations can result in fines and penalties. Sixthly, alternative solutions. There are safer and more code-compliant ways to feed a sub-panel. These include using a dedicated breaker in the main panel or installing a separate disconnect switch. A dedicated breaker in the main panel provides overcurrent protection for the sub-panel. A separate disconnect switch allows you to safely disconnect the power to the sub-panel. Seventhly, manufacturer's instructions. Always follow the manufacturer's instructions when installing electrical equipment, The manufacturer's instructions will specify the approved methods for connecting conductors and equipment. Failure to follow the manufacturer's instructions can void the warranty and create safety hazards. Eighthly, professional advice. Consult with a qualified electrician before making any changes to the electrical system. An electrician can help you determine the safest and most code-compliant way to feed a sub-panel. Electricians have the knowledge, skills, and experience to safely and properly install electrical systems. Ninthly, risk assessment. Assess the risks associated with using the lugs as a feed-through. Consider the potential hazards such as overheating, fire, and electric shock. If the risks are too high, consider an alternative solution. Tenthly, documentation. Document all changes made to the electrical system. This will help to ensure that the electrical system is properly maintained and that future work is performed safely. Create a wiring diagram that shows all of the circuits in the electrical system. Keep a record of all inspections and repairs. By understanding the potential issues and hazards associated with using the lugs as a feed-through, it is possible to make informed decisions about how to safely and properly feed a sub-panel. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. In addition to the technical aspects of the installation, it is also important to consider the legal and regulatory requirements. Here are some key points to keep in mind. Firstly, electrical codes. Electrical work must comply with the NEC and local codes. The NEC is a set of standards for electrical installations that is adopted by most jurisdictions in the United States. Local codes may have additional requirements that are specific to the area. Secondly, permits. In most jurisdictions, a permit is required for electrical installations. A permit is a document that authorizes you to perform electrical work. Permits are typically issued by the local building department. Thirdly, inspections. Electrical installations must be inspected by a qualified electrician or electrical inspector to ensure that they comply with the NEC and local codes. Inspections are typically required before the electrical system can be energized. Fourthly, licensing. Electrical work must be performed by a licensed electrician. A licensed electrician has the knowledge, skills, and experience to safely and properly install electrical systems. Licensing requirements vary by jurisdiction. Fifthly, insurance. Electrical contractors must carry insurance to protect themselves and their customers from liability. Insurance can cover damages caused by electrical work. Sixthly, warranties. Electrical equipment typically comes with a warranty. The warranty covers defects in materials and workmanship. Read the warranty carefully to understand the terms and conditions. Seventhly, contracts. Electrical work should be performed under a written contract. The contract should specify the scope of work, the price, and the payment terms. Read the contract carefully before signing it. Eighthly, dispute resolution. If a dispute arises between you and an electrical contractor, there are several ways to resolve it. These include mediation, arbitration, and litigation. Mediation involves a neutral third party who helps the parties reach a settlement. Arbitration involves a neutral third party who makes a binding decision. Litigation involves filing a lawsuit in court. Ninthly, consumer protection. Consumers are protected by a variety of laws and regulations. These laws and regulations protect consumers from fraud, misrepresentation, and unfair business practices. Tenthly, due diligence. Before hiring an electrical contractor, it is important to do your due diligence. Check the contractor's license, insurance, and references. Get multiple bids and compare prices. Read reviews online. By understanding the legal and regulatory requirements, it is possible to protect yourself and ensure that electrical work is performed safely and properly. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. When selecting a sub-panel for installation, several factors must be considered to ensure it meets the electrical needs and safety standards of the application. Firstly, amperage rating. The amperage rating of the sub-panel should be sufficient to handle the anticipated load. Calculate the total amperage required for all circuits connected to the sub-panel, including both existing and future loads. Choose a sub-panel with an amperage rating that exceeds this calculated value to provide a safety margin. Secondly, number of circuits. Determine the number of circuits required for the sub-panel. Consider the number of lighting circuits, receptacle circuits, appliance circuits, and any dedicated circuits for specific equipment. Select a sub-panel with enough available spaces for all required circuits, with some additional spaces for future expansion. Thirdly, main lug or main breaker. Decide whether a main lug only or a main breaker sub-panel is needed. A main lug only sub-panel requires a separate overcurrent protection device, such as a circuit breaker, in the main panel to protect the sub-panel. A main breaker sub-panel includes a built-in main breaker that provides overcurrent protection for the sub-panel. Fourthly, voltage rating. Ensure that the voltage rating of the sub-panel matches the voltage of the electrical system. Residential electrical systems typically operate at 120 volts and 240 volts. Select a sub-panel with a voltage rating that is compatible with the electrical system. Fifthly, enclosure type. Choose the appropriate enclosure type for the sub-panel based on its location and environmental conditions. Indoor sub-panels are typically housed in NEMA 1 enclosures, which provide protection against dust and accidental contact with live parts. Outdoor sub-panels require NEMA 3R or NEMA 4 enclosures, which provide protection against rain, snow, and ice. Sixthly, mounting location. Consider the mounting location of the sub-panel when selecting a model. Sub-panels can be surface-mounted or flush-mounted. Surface-mounted sub-panels are mounted directly on the wall. Flush-mounted sub-panels are recessed into the wall. Seventhly, wire size and type. Determine the appropriate wire size and type for the conductors connecting to the sub-panel. The wire size must be sufficient to handle the amperage load of the circuits. The wire type must be compatible with the terminals in the sub-panel. Eighthly, grounding and bonding. Ensure that the sub-panel has adequate grounding and bonding provisions. The sub-panel must be properly grounded to protect against electrical shock. The sub-panel must be bonded to the grounding electrode system. Ninthly, compliance with codes and standards. Verify that the sub-panel complies with all applicable codes and standards, such as the NEC and UL. Look for a UL listing mark on the sub-panel. Tenthly, manufacturer reputation and warranty. Choose a sub-panel from a reputable manufacturer with a good warranty. A reputable manufacturer is more likely to produce a high-quality product that will last for many years. A good warranty provides protection against defects in materials and workmanship. By considering these factors, it is possible to select a sub-panel that meets the electrical needs and safety standards of the application. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards.